So Margaret was doing her homework. It's a nice idea to do. When her dog bit off a piece of the paper. Bad dog. She had left. All she had left was the start of some sequence, 412, and the fact that 972 was some term in that sequence. Somewhere along that sequence, you get the number 972. So first of all, could the sequence be arithmetic, right? Could it be an arithmetic sequence? Well, I can't say no. If I only have those two terms, certainly it could be. In fact, what would be my generator if I only had those two terms and it was arithmetic? 8. Thank you for saying add 8. Right? Add 8. Why? Because you could multiply by it, and that's a different sequence. Add 8 is great. So, yeah, it could be. Yes, this could be arithmetic. And my generator would be adding 8. And if I wanted to write down the general rule, what would it be? Well, take a look, guys. T of n, the nth term, would equal. And by the way, more of you got this right. More of you knew how to write down a general arithmetic sequence than geometric one, but still many of you didn't have this quite right. So look at the general rule. This is going to be every single time the common difference. I'll use the variable a. This is what you're adding each time. Common difference times the variable n. Now I know, look at it, guys. We're multiplying, but we have a common difference. We're adding the same thing each time. Remember, multiplication shows repeated addition. That's exactly what Elijah was just thinking. It shows repeated addition. So if you want to add a plus a plus a, that's a times 3. If you want to show a plus a plus a plus a, 4 of them, that's a times 4, right? So multiplication allows me to show keep adding, keep adding, keep adding. And then we need to include the 0th term. Oh, that's interesting. What would be the 0th term here? It would be -4, right? How did you get the 0th term as -4? Okay, so we can see that if you're starting, if this is your first term, I don't mean to make that look like a fraction, I'm sorry. If that's your first term and this is your second term, the 0th term right here, we're just going to follow this pattern backwards only once. So we're going to take 4 and subtract 8, and when we do that, we're going to get -4. So this is plus the plus b, and this is the 0th term. 0, I'll write 0 term, right? What else did we call this? The initial, I don't know. It doesn't show up in the sequence, but it's the 0th term. We got that down. Now, for this particular problem, again, if we write this, it's pretty straightforward, right? The nth term is going to be 8 times 8 times n, and then minus 4, because 4 is my 0th term. So it definitely could be arithmetic. That would be the equation for the nth term. Look, you put any n in there, and you're going to get what term number that is. Now, there's one more part to this equation, right? We've said, yes, it could be arithmetic. Here is the equation of the nth term. The one more thing that we're missing, though, is what term number is the number 972? So in other words, what value of n, what natural number n, when I put into that equation, would make this equal the number 972? And to answer that, I'm going to just zoom out over here, and I'll do it in a little blank space. It looks like this. I'm looking for 972, and what I'm looking for is when 8n minus 4 produces that. Look at it. I want to know when 8n minus 4 is 72. It's the most rational, logical thing to write down. To solve this, it's pretty straightforward. We're going to add 4 to both sides, right? So we're wanting 876. When is that 8n? And if I divide both sides by 8, what did we get? We get 122. So that means the 122nd term will be the number 972. You don't believe me? Plug it into the equation I came up with. Still don't believe me? I don't care. Sit there with a calculator all day and keep going. Plus 8, plus 8, plus 8, plus 8. And keep track of how many times you add 8. But you're going to get up to the number 972 after you've done it 122 times. All right, next part of this question is, could this sequence be geometric? If so, what is the equation of the nth term? So first of all, if it is geometric, Troy, what's the generator? And I want you to think about it and then say the right complete thing. It was a sequence. It was started with a 4 and then a 12. Same sequence. What's the generator? Yes, sir.
Oh, you're multiplying by 3. Multiplying by 3.
That's correct. Thank you for those of you that raised your hand also. Yes, we're multiplying by 3. So, yeah, if I've only got a 4 and a 12, yeah, 4 times 3 is 12. Times 3 is 36, right? Times 3 is some other number. I don't know it. I'm sorry. So, yeah, this is, yes, this could be geometric, and my generator to be multiplied by 3.
Wait, how can it be geometric? Because what are you going to get to multiply to get 4?
Guess what? What's 4 divided by 3? Hey, it's not a trick question. Look, here's what 4 divided by 3 is. 4 divided by 3. It's a fraction, 4/3. Right? So what is that 4 divided by 3? What is that called? My 0th term. Now, how did I get it? I got it by not freaking out because it's a fraction. I got it by not being discriminatory against non-natural numbers. I was thinking 4/3 is a fine number, right? Now, if I multiply 4/3 by 3, what do I get? Yeah, because why? Because it's 4 divided by 3 times 3. 4/3 times 3 is just 4. What's 4 times 3? You have no problem with that because it's a natural number. You're like, 12, that's right. We're down with that. So anyways, we now have our 0th term, and we also have our common ratio. We're multiplying by 3. Now, come back up, and you can look at this previous problem right here. I want you to think about that. The nth term is your 0th term times your common ratio raised to the nth power. So what would be the equation for this if it was a geometric sequence? What's your 0th term? 4/3. What's your common ratio? And then raised to the nth power. Look, when n is 1, 3 to the first power is 3. What's 3 times 4/3? 4. Guess what? If I put 1 in there, I get the number 4. Do it again. If you put in the number 2, 3 squared is 9. 9 divided by 3 is 3. 3 times 4 is 12. This is exactly the equation that would generate 4/12 continuing if it's geometric. All right, then the last question here is, this is kind of tricky, right? This one takes a little bit of hunting for the answer. But let's think about it. The other part, by the way, if I'm circling this, yes, it could be geometric. We're multiplying by 3, and the 0th term is 4/3. This is the equation of it. Now, if this is the case, what's the value of n that would produce 972? Now, listen. If I solve this and n's not a natural number, and she's claiming that n is part of the sequence, then it couldn't be geometric. What? We just said it could. Well, look, if she knows that 972 is in that sequence, and we don't get it, it's not. So let's try this. So 972 equals 4/3. That's a terrible looking 3. 4/3 times 3 to the nth power. Okay, now, look, if I take 972, what times what?
324.
Why 324?
Oh, it's just 3 times 324 equals 900.
I'd like you to do this. I'm going to multiply both sides of this by 3/4. Okay, does this freak you out? If I multiply both sides by 3/4, it gets rid of the fraction on the right-hand side. Does that seem okay? So I can do this. I'm going to multiply. So this is going to be 3/4 times 972. Get that on your calculator. Be ready with it. And over here, I'm going to multiply 3/4 times 4/3 times 3 to the nth. Now, the thing is 3/4 times 4/3 is 12/12. This value right here is just the number 1. It's a 3 over 4 over a 3 times 4 over a 3 times 4. It's a big 1. Did anyone get this big number? 7. Is it?
729.
Okay, so this is 729, and that's going to equal 3 to some power of n. Now, we do not have the mechanics right now to solve this the way that I've always taught students how to solve this, right? Because that would happen in an Algebra 2 course, and normally you guys would take geometry, then Algebra 2. So try this with your calculator. Go 3 to the third. What is it? 27. You knew that, right? You saw it coming. What's 3 to the fourth? What's 3 to the fifth? Okay, what's 3 to the sixth? Exactly. Okay, so here's the thing. When n is equal to 6, 3 to the n power is equal to 729. This is exactly the value. Now, fortunately, these exponential equations grow rapidly, right? So you're not going to have to go all the way up to 122 checking. Now, if I got that and I got like 710 and then the next one was 700, in other words, if it didn't hit 729 exactly, I would have to say, no, this couldn't be geometric, right? Because why? Because 729 is part of the sequence. But in this case, it is. And it is exactly when n equals 6. So that's the other part, right? So, and I didn't have the other part over there, but yes, that's the equation. And when n is 6, this is exactly what we want it to be.